Hello class, this is Mr. Reynolds, and hopefully you just saw a video of me taking a damp paper towel and wiping a little bit of the floor with it and watching any dirt molecules might be around. Most dirt molecules have charges, and they will attract to a solvent that has charges. And a rule is like dissolves like. Okay, so solutes with charges will dissolve in solvents with charges. All right, solutes without charges will dissolve in solvents without charges. Okay, there's a lot of terminology here. It really comes down to two things: either it's got charges, or this substance has no charges. All right. If we say it's polar, well, that's got charges. And usually they'll say inorganic. Inorganic means it has charges also. Okay. And we've done a lot of inorganic compounds. Any metals bonded to nonmetals, sodium, column 1, bonded to chlorine, column 17. Magnesium bromide. Okay. Magnesium is column 2. And bromine column 17. So plenty of inorganic compounds, tons of those. If the word says nonpolar, that means it doesn't have any charges, and typically organic means it doesn't have any charges. You learned this word organic before me. It contains carbon. If it contains carbon, usually it's an organic substance. And these long chains of carbon surrounded by hydrogens that you learned before, these hydrocarbons, pretty much all hydrocarbons are sharing electrons pretty evenly. I mean, the carbon sharing to carbons on either side of it, and all of them are sharing to some hydrogens around it. There's no differences in those. They're all sharing pretty much the same. They don't have any charges. They're nonpolar. Okay, so you learned some of these things already on it. Again, solvent was a solute and solvent. Solute and solvent were parts of a solution. They were two parts of a solution. A solution is a mixture where one thing dissolves in the other. The solute particles would dissolve in the solvent. If we had a beaker of water and sprinkled some salt in there, the salt dissolves. The salt would be the solute. The water would be the solvent. Okay, onward. With water, water is extremely unique. Okay, you learned water some already. Okay, you know it's H2O is its chemical formula, its structural formula. We showed this. You did some of this just the other day. You did some Bohr models of these also, and this is critical because where the bonds are between them, those are electrons that are being shared. 2 electrons here, one from this hydrogen, one from oxygen. In this bond, 2 electrons, one from hydrogen, one from the oxygen. Okay, so as we do this Bohr model sketch, we'll use this. Well, we'll be able to see things on this. Okay, so oxygen, 8 protons, 8 neutrons, 2 shells, 2 on the first, 6 electrons on the second. Okay, and we're going to share with a hydrogen. There's my 1 proton for hydrogen. There is its 1 electron. For another hydrogen, here is its electron. So this is a water molecule with 8 protons, 8 positive protons compared to 1 positive proton, and these 2 electrons right here are being shared between these 2 atoms. Gee, where's the electron going to spend most of the time? The negative electron is going to be around this oxygen most of the time. Okay, so if we have more of these electrons around, hanging around the oxygens more as they're being shared, the oxygen is going to have a negative charge. If the electrons are gone from the hydrogen, kind of spending more time going around the oxygen, well, we have a lot, just the hydrogen, the proton exposed down here. Okay, so we have a positive end. So most on water molecules, they're considered a polar molecule. Okay, actually the old name is, until it became politically incorrect, the old name is bipolar molecule. Okay, where it's got both charges on opposite sides. You'd think it's pretty common. It's not. Water is extremely unique. There's lots of things out there with charges, but they have one charge. Things that might have a couple charges would pretty much be on a similar side, but distinctly on one side or the other, water is very, very, very unique. Okay. So again, with an uneven sharing of electrons, we get more of them around the oxygens, so it's usually a little bit more, we can pick up more of a negative charge on it, and on the hydrogens, we pick up more of a positive charge. All right. So let's go to another clean slide on this. Let's say that we drop sodium chloride in water. Okay, metal bonded to non-metal, positive, negative charges, and they come apart, they dissolve. We can see that happening. It happens easy. If we drop it in water, we've got, if we drop the sodium in here, it's a positive charge. The only reason these two are attracted is because they're opposite charges. Okay, so if we throw them in a big solvent that has charges like water, we'll have the oxygen end of the water molecules attracting to this positive part. Okay, remember the oxygens are negative. Okay, I haven't finished the molecule yet, but each one's a water molecule, right? Pluses on the hydrogens. Water molecule. Let's make each of these a water molecule. So that positive sodium is attracted to the negative part of the water, which is the oxygen atom. Okay. Meanwhile, the chlorine, the negatively charged chlorine, well, hey, water's got the charge for that also. Okay, it's just here on the hydrogen end. So water is going to surround itself around this chlorine. Chlorine's negative, so the positive part of the water, the hydrogen, is going to attract to that. All right. The positive hydrogens will attract to that. And thus they dissolve. The sodium chloride dissolves. It disappears in the water. Okay. Okay, on this, I want to make this the last slide. So basically, we're going to have things with charges. It's either got charges or it doesn't have charges. Okay, we're going to list out some of the different names that you're going to see here. If it's got charges, we may say it's polar. Okay, you may see the word, without any charges, it's a non-polar substance. Okay. Usually polar things, if it's inorganic compounds is metals plus charge to non-metals, negative charge. Inorganic. So usually inorganic means charges. Organic means no charges. You may see these words also. Hydrophilic means, it's attracted to water because it's got charges. Hydro means water. Philic means love. Okay, it loves water. Hydrophobic, it's afraid of water. It faces away from water. It doesn't like water. I have a phobia to water. Basically, it doesn't have any charges. Okay, a rule to review, we said like dissolves like. We've got a lot more to do on this, but there's a handful of things that you can do. And hey, it's got charges, or the substance doesn't have charges. We have, if we were doing paints, we'd be talking no charges, oil-based paints. If it has charges, water-based paints. You can clean the paintbrush just putting it in some water. Okay, we mentioned before oil and water do not mix. That's with one of those, like with one of those salad dressings, you got to shake it up right before you pour it on there to mix them up because they will separate out. If you're walking out in the parking lot with the blacktop that has some oil put on there, you might see the rainbow. If it recently rained and there's a puddle, you might see the rainbow on the top of it where there's some oil floating on top of the water. And a key here is they do not mix. No charges and no charges do not mix. Okay, like a polar solid dissolves in a polar solvent, and a nonpolar solid dissolves in a nonpolar solvent. A nonpolar solid dissolves in a nonpolar solvent. Okay, now I'm going to ask you some questions for you to do on OneNote, and thank you very much.